All right, great guys. Let's try to do something interesting. Today we are going to be dealing with some questions on Chebyshev rules and Empirical rule. So without wasting our time, let's see some questions and let's see how we can deal with them. This is question here. At a local high school, GPA are normally distributed with a mean of 3 and standard deviation of 0.6. So what percentage of students at the high school have a GPA between 2.4 and 3.6? This is a reasonable question. That's very interesting. So how are you going to deal with this if you are given a kind of question like this? Let's see. First thing we should notice is that we are given the mean. The mean is what? 3, and the standard deviation is 4.6. And do not forget, the question says it is normally distributed. In that case, you should know that what you are going to use is what we call empirical rules. Now, and what does empirical tell us? We know from the empirical rules that when you deviate by one standard deviation to form the range, then about 68% should be between that range. And if you are deviating by 2 standard deviation, about 95%, 3 standard deviation, about 99.7% approximately. Okay, now let's see how much can we deviate to get this range which was given here. We have 2.4 and 3.6. In fact, when we are given a question like this, I do tell my students that you don't even need to work most of the time, because in fact, you can get your answer straight and forward. Let's see what I'm trying to say here. As you can see, the mean here is 3. The standard deviation is 4.6, and I was given 2.4 and 3.6. In fact, all I should just think is, how can I get 2.4 using this mean and standard deviation? I can easily note that I need to subtract 0.6 from here to get 2.4. And in fact, to get 3.6, I need to add 0.6 to this. In that case, that means I'm adding one standard deviation. Since my standard deviation is the same thing as 4.6, which I'm adding and subtracting, in that case, I can easily say that I only need one standard deviation. In fact, if I deviate from one standard deviation, I will get this and this. And that means using one standard deviation when you are dealing with normal distributed data, do not forget, empirical say 68% of them should lie between that range. In that case, I can say A is my answer without even writing with pen. But this is a simple calculation or the solution if you wanted to write this down. The mean is this, the standard deviation is this. Deviating by one standard deviation, you get 0.4. By one standard deviation, you can still get 0.6. And according to empirical rules, we know that 68% should fall between this. In that case, A is the correct answer. I hope you understand that. Let's see question 2. Given a mean of 75 and a standard deviation of 7, how many students out of 500 will score higher than 68, assuming the data is symmetrically distributed? In fact, this question also is an example of normal distribution data. Remember, one of the properties of normal distribution data is that they are symmetric. So the question saying this is symmetrically distributed. Definitely, this will be empirical question. So in that case, I already know I'm going to make use of empirical rules here. So let's see how much this thing deviates from the mean. So the range I was given, okay, I was not given any range here, but the question is asking me that, what would we do? Okay, the student that score higher than 68. So that means my target should be the word 68 itself. Now let's see, how can I get 68 using this mean and standard deviation? Without telling you, you should know that if you can subtract 7 from this 75, this should give you 68. In another way, another easy way you can easily know how much a data deviates from the mean is to just subtract that data from the mean. For example, I will say 75 minus 68. Or you say 68 minus 75, you still get 7. In that case, 7 divided by 7 telling me that I only need one standard deviation. So one standard deviation is needed here. And you should be very careful. You should know that if you are deviating by one standard deviation, here you are subtracting to get 68. If you had, you are going to get 82. So that means between 68 and 82, about 68% of them should lie between that, according to empirical rules. Since I'm using one standard deviation, that's what I showed you here. But the question is asking me, how many of them score more than 68? 68. So the score higher than 68, let's see how to deal with that. Since we are sure that 68% will be between 68 and 83, that means 68% of them will score between 68 and 83. In that case, the remaining are going to be outside this range. In that, what we are trying to say is that about approximately 32%, if you subtract 68 from 100, you have 32. So 32% are going to be outside this range, which can also be interpreted as 16% will be below the range, I mean below 68, while the remaining 16% would be above 83. Because in fact, when you say something is symmetric, that means whatever be at the right will be at the left. So that means we can divide that 32 into 2 and say 16 below the range, 16 above the range. So if 16 is above the range, now let's see. The question asks us how many of them score higher than them. Now, let's see how to deal with that. Since I know that those people that are going to score below the range is 16%. Now, in fact, logically, if you think, those people that score below the range means they are going to score below 68, which is the mark that is here. So that means those people that are going to score above 68 and above would be those people that score between 68 and 83, and those people that score above 83. So if you check here, those people that score between these two range are 68%. Those people that score above them, they are 16%. So you can add 16 to 68, and that will give you 84%. In that case, we can say 84% of them are going to score higher than 68. That's one simple way. Another way you can also do this, that since we know that 16% score below this range, that means those people that are going to score below 68 here will be 16%. And that means those people that are going to score higher will be 100 minus 16%, which is another way to get 84%. So you can do it in any way you like. Either you add those people be between these two range and those people above the range together to get 84, or you just get the value of those people that are below the range, which are 16%, subtract them from 100 to get those people that score higher than that, and that will give you 84% also. I hope you get that. Okay, I think we can proceed with that. Okay, let's proceed and see what we have. So I believe you understand how we have that question. It is very easy and very interesting to solve. Now we should take a look at another question and see how we can deal with it. Let me show you another question. Another question is here. Oh, sorry. Okay. Now the question asked from the same question we are dealing with the other time, that assuming that the pass mark of 17, okay, assuming the pass mark is 75, how many students pass? This is another very critical question. Remember, the question is about the mean is 75 itself, and we are given the definition to be 7. Now the question is now asking us that if it happened that the pass mark is 75, that means we are indirectly saying that those people that score 75 and above, we are trying to calculate the percentage of that. But that is not all. We also need to get the number of people, because the question asking how many students pass, not in fact the percentage. Assuming the question is asking percentage, we know, but this question is how many. That means they are asking the numbers of students that's going to pass if the pass mark is 75. Now let's see how I'm going to deal with that. If you check the question, you realize that the mean is 75. In fact, this is straight and direct. You don't need to calculate anything. You might wonder why. Let me tell you this. You know, mean is 75, and the question says this thing is normally distributed. And when the data is normally distributed, remember one of the properties is that the mean, median, mode are always the same or approximately equal. In that case, this is telling me that if my mean is 75, definitely my median also will be 75. How interesting. If the median is 75, if you learn or understand much about interpretation of the median, you would have understand that when you say the median is 75, you are telling us that indirectly that about 50% of the data are above that, and about 50% of your data are below that. So in that case, median being 75 is telling me that 75% of the students are going to score 75 and above, while 75 of them are likely to score below. So in that case, sorry, 50% rather. In that case, 50% score 75 and above. So I can actually use that and use it to make my interpretation. I already know how much I'm going to have. Another thing you can also get to know that the answer is 50% is that if you observe the way normal distribution curve always look like, you will realize that every normal distribution score, every normal distribution curve, you realize that if you are to divide them into half, you realize that the center is exactly where the mean always is. Exactly where the mean always is always the place that divide the normal distribution curve into two, or let me say into equal half. So in that case, you can use that to interpret this question and say 50% of them are going to score 70 and above. So that means 50% of them will pass. In that case, we can apply that to number of students we have. In the question, if you check, the number of students we are given here is 500. The question says the students out of 500. So if 50% of the students pass, that means 250 of them score or have the pass score. So in that case, the question is easily solved. We can say 50% of them, and that gives us 250. So we can say 250 students passed the exam or the test. So that about that. That's very interesting, I believe. Now let's take a look at another example. Another example here is a computer from a particular company are found to last on average for 3 years without any hardware malfunction with standard deviation of 2 months. At least what percentage of computer? In fact, without telling you, whenever you see question talking about at least, at most, minimum, or maximum, just know this question have to deal with Chebyshev rule. That's another logic. Whenever the question is using some terms like minimum, maximum, at most, at least, not less than, not more than, just know it has to do with Chebyshev rule. Because Chebyshev rule is not precise and it's not about approximation. So in that case, let's see how to do with this. Without telling you, I already give you the hint that this is going to be Chebyshev rule. And let's see the question. The question asks us, at least what percentage of computer lasts between 32 and 40? So this is very easy. Just check what is the mean here. The mean here says 3 years. You have to be very careful in writing a question like this. And you are given the months to standard deviation to be 2 months. And in fact, if you look at the question given, it is in form of months. And that means here you are to firstly convert the years you have here into months. So 3 years can be converted into months. That will give you 36 years, or 36 months rather. Because in fact, a year is 12 months. So that means 3 years will be 3 times 12, and that is 36 months. So that means indirectly, the average year or the mean year is 36 months. Now, observe 36 months and 2 months with the range you are given. How can I get 32 using 2 and this 36? In fact, it is very clear that all I need is 2 standard deviation. If I can make use of 2 standard deviation here, you realize that we have 32. Because in fact, 36 minus 4 is 32. And that 4 is being gotten by multiplying 2 standard deviation by 2. Okay, check the 40 months that we have also. The mean is 36. This is what we are doing here. Let me show you the calculation so that it doesn't seem like a magic. Mean is 3 years and we get 36 years. Standard deviation is 2 months. So if you subtract 2 standard deviation from the mean, you are going to get 32. If you add 2 standard deviation, you are going to get 40. And that means 32 and 40 that were given here, it's confirmed that 2 standard deviation is needed. And when you are making use of 2 standard deviation, according to Chebyshev rule, we know that about 75% of our data is going to lie between this range. We know that if you are using 2 standard deviation, at least 75% of data, that's an error, not about, at least. Remember, Chebyshev rule is all about at least, at most. So that means at least 75% of our data will fall between that range. But what's the question? Yes, we've solved the question set. So that means in this question, should we say there is answer or not? For this question you are looking at, you can see there is no answer there. Because in fact, you are using 2 standard deviations. So at least there will be 75% of data between this range. So that's what we should have as the answer. So no answer in this question. That's just it. Although some people will say the answer should be 95%. Some people might also wanted to pick 95%, but that's not going to work here. Because in fact, we are using 2 months. There's no answer. That's just the perfect way to say it. Just say there's no answer there. Now look at another question here. The mean score in an accounting test is 80 with a standard deviation of 10. Between which scores must the mean lies to represent at least 88.89%. That means here you are given percentage, and all you are asked to do is to get the what? Yes, you are just to get the range. Now let's see. This 88.89, this does not correspond with empirical rules. That's another thing. Because in fact, all those percentage you can have in empirical, you already know them. They are like 64, 68%, 34%. Sorry, yeah, you can have 68, 34, you can have 95, you can have 99.7. Those are the percentage that you are likely to see when you are dealing with empirical rules. But this 88.89 corresponds with 3 standard deviation that was stated in Chebyshev rule. So that means this thing is going to work out with Chebyshev rule. And this 88.9 is stated in Chebyshev rule that if you are deviating by 3 standard deviation, at least 88.89% of your data will lie between that. So that means indirectly, all I just need to do is to deviate by 2 standard deviation from the mean. Now, what is my standard deviation? That is 10. So if I make use of 2 standard deviation here, I will have 2 times 10, that is 20. Subtract 20 from this 80, I have 60. Add 20 to this 80, I have 100. In that case, that means my range will be 60 to 100. This is the calculation here. This is what I've just done. You can see it is very easy to. Oh, sorry, I almost made a mistake. Sorry, this is 3 standard deviation we are using. Don't get me wrong. It is 3 standard deviation according to Chebyshev rule. So that means 3 times 10 with 30. 80 minus 30 will give us 50. You can see. So, nobody's having a mistake. You have to be very careful. That's why you should master the rule very well. So this will give me, in fact, 50. And if I add 30 to it, that will give me 110. So it's 50 to 110. So and that is the correct answer. I hope you got that too. Yes, let me do this last example, and very interesting and very, let me say it's a little tough. Look at this question, read it well. You can pause the video, realize you are given the mean and you are given the standard deviation. But the question here is a little tricky. The question asks, what would be the range between 1120 and 1180? Let's see. If you try to observe this question, if you use 1 standard deviation to the mean, you are going to get 1170. If you use 2 standard deviation, you are going to get 1190. And that means 80 and 120 here is not gotten. Because if you use 1 standard deviation, you don't get this. If you use 2 standard deviation, you don't get this. So what standard deviation should you have? Whenever you have a question like this, just know it's Chebyshev rule. So the way you can actually get your answer is to find the value of your k. How much can you deviate from the mean before you can get this range? And one easy way to get that is to subtract this thing from this, subtract mean from this, then divide it by standard deviation. See how I do my calculation. This is the mean that was given, and this is the value I have. So I will subtract this from this, I get 1.5. I will subtract this from this, I get 1.52. I mean, find the difference between the mean and the range that you are given, then divided by standard deviation. This is telling me that all I need here is 1.5 standard deviation. Go and check well. This is what we are saying. The mean is 1150, the standard deviation is 20. If I can use 1.5 standard deviation, or I should say 1.5 standard deviation here, you will see that I will get 1108. Because in fact, 1.5 standard deviation here is going to give me 30. Do you get that? 1.5, that means 20 and 10. So I will have 30. 30 plus 1150 will give me 1180. And if I subtract 30 from this, I will get this. So that means 1.5 standard deviation is used to formulate this. What I'm trying to let you understand here is like, it's not all the time you'll be given a value like 1, 2, 3. Sometimes you may be given decimal value. So what you should just do is to subtract them, divide it by standard deviation to get the number of standard deviation you need. So that means here, my value for k, or the number of standard deviation I'm using is 1.5. But do not forget how we formulate empirical or Chebyshev rule is that we do 1 minus 1 over k squared. So since I know the number of standard deviation I'm using here is 1.5, I will substitute the formula 1 minus 1 over k squared. So substituting this here, I will have 1 over 1.5 square. Sorry, the square is supposed to be here. This is square, 1.5 square. So I have, I can change this 1.5 to 3 over 2. So if I square it, I will have 9 over 4. So 1 minus 1 divided by 9 over 4. If you use the law of division, when you have two divisions, you can change it to 4 over 9. So 1 minus 4 over 9 here will give you 5 over 9. So in fact, 5 over 9 of them is going to fall between that. You can convert it to percentage and say 55.56, where you multiply by 100. So that's the percentage. And check the answer here. Question is in this one. This is a little tricky and very interesting. So you have to be very careful. This is not always common, but sometimes examiner or the question might be tricky and give you this kind of question. So that's the perfect answer to that. I hope you enjoyed this video. I thought you like this. Just consider to subscribe, and you can drop your comment in the comment section. If you have anything or any worry, I will always give record and more explanation on this. Thank you for being here. You are blessed. Next time, we shall have another class. Bye.